Hey guys, okay, let's welcome ourselves to our very first actual Algebra 2 lesson. We are going to start parent functions and parent function transformations. So there is a lot of information that I need you guys to have down in your notes. So you're going to label it parent functions and parent function transformations. I've told you we were going to be studying about 9 parent functions this year, and we're going to just keep filtering them in with each conversation. I have a huge graphic organizer that I'm going to have you guys work with that I kind of want as we learn each function. We're going to track it in this way so we can use a vocabulary. So I'm going to step out of the way so you can pause the video and get everything that you need covered. I also want to let you guys know as we begin this, we have an essential question that we're going to be working our way towards at the end of this unit. How will I analyze and graph a or an and linear absolute value function, and how will it be affected by various transformations? So we're starting off with 2 functions simultaneously. We're going to learn, we've already learned about lines, and I just want to make sure that's really solid. And then we're going to instantly switch over to absolute value functions where the transformations get really fun and they're easier to see than they are in linear functions. Okay. So first off, we are going to start with the fact that we have a parent function. This is f of x equals x. That parent function is called a linear function. So it has a name. So parent function is the linear family. So anything that's different from f of x equals x means that there's been a transformation done to it, and we'll get into what those look like, but we're going to start with just learning the language and the behavior of that. We're also going to focus on domain and range. Like I told you guys in class, that's going to be a big part of what we talk about for every single function. So going old school, for anyone who's still not safe graphing lines, I want you guys to get to a place where you're comfortable and realize that if you don't know how slope works, that's kind of okay because you can still work around it. You just have to constantly use a t-chart. Now, this is where you get to pick all of your x values and then you plug them into your equation and produce your y values. So if I wanted to plug in -3, I would plug it in, replace my x. So I would get a formula like this. I would get f of x equals -3. Now what I need you guys to recall is that f of x is y. So when I plugged in -3, I got -3 out. So I would go to the ordered pair -3 comma -3. And I would have that to graph. And that happens every single time. If I plug in -2, I just get that 1, 0, 1, 2, and 3. And this chart gives me all of my intercepts that I need. So I'm going to go, it's actually all my points that I need. I'm going to plot 0, 0, 1, 2, 3, 4. Sorry, I went further than the actual graph does. And connect. Parent function. I want to describe what's going on with this parent function. So I know when I do a transformation, how is it going to be different? What should look different from this function right here? Because they're all going to be children of this one parent function, okay? So we have a list of vocabulary that we can use to describe what we see. So I have a linear function that happens to be increasing, so that's one of our vocabularies. I have a linear function that's increasing. I know it's increasing. It's got a positive slope. That means to increase. If this was a negative slope, it would be decreasing. Remember, it would go left to right. It would go down. So a linear function increasing. Now, part of learning how something's increasing is you want to state where is it increasing. Does it increase forever or does it increase for little sections? And if it increases for little sections, then we want to go ahead and notate where those little sections are. This is called interval notation, and it's going to be the first thing that you learn. So essentially, this line is increasing forever. It will constantly go up. It's what it means to be a positive slope. So what I would say is that this thing is increasing from -infinity to infinity. That just tells me it increases forever. Up next, I want to talk about where its x-intercept is, where its y-intercept is. You're giving me all these descriptions, so if I never saw the picture, I could actually go and graph it without ever knowing anything about it. So you would tell me it has an x-intercept and a y-intercept at the origin, at 0, 0. And that's this right here. You can see where it crosses the x-axis and it crosses the y-axis, and it crosses in the same location, which is totally fine. Up next, we want to talk about whether it has a maximum or a minimum. A maximum or a minimum is the tallest point or the lowest point. Well, if this thing goes up forever and it goes down forever, then it can't have a tallest point or a lowest point, because there's always going to be one more point taller or one more point lower. So this has no max or min. And we're just kind of making our way through all of the vocabulary. It doesn't have a vertex. A vertex is where two things come together. We do need to have a conversation about end behavior. End behavior is what happens when life goes out to the infinities. Specifically, where do the x's go? What are the y's doing? So end behavior talks about as you move along on the x-axis, where do the y's go? And I don't mean like in the small picture. I mean like in the 20,000, if I plugged in 20,000 into this function, what type of y value would I get back out? And we want to state that the end behavior, it has funky notation. So what it says, as x approaches, and that's what that arrow means, it means to approach. As x approaches infinity, so as I crawl onto the x-axis and I keep going out and out and out and out, where does the function go? And you can look, as I come out, the function is heading upwards. So we would say that f of x is approaching positive infinity. So as I go out on this axis, the function itself goes up forever. And we go the other way. Well, what happens as you approach all the negative values? Well, as I go towards negative infinity, as the x's go out this way, if I want my arm to match the graph, I have to make it go down, and now they're going in the same direction. So the y values are heading towards negative infinity. So they are approaching negative infinity. And last but not least, we want to talk about domain and range. And the best thing I can say is domain is a list of all of your x values, all of them. The range is a list of all of your y values. Well, if this goes up forever and that goes down forever, and we just got done stating that we can go out on the x-axis to negative infinity, and the function's doing this, and it never stops because there's arrows at the end of it. It never stops. Then my domain is what we call the set of all real numbers, which we learned about the real number system. So that means it includes every decimal, every fraction, every whole number, every negative, whether the decimal stops or the decimal goes on forever, it's included. That is why we connect the dots, so we can include every single infinite number in between 1 and 0. There's an infinite amount of numbers, and we just included them. So we're going to say that our domain, our set of x values, is all real numbers. Remember, that's the double-legged R. We also say that our range is also all real numbers. And I want to give you what that would look like in interval notation. That would be from negative infinity to infinity. And honestly, I don't care which notation you use. You can use the shorthand for all real numbers, or you can use the interval notation. Now I'm going to pause this video because it's getting a little long right here, and then we're going to come back and we'll fill in the rest of the stuff, okay? Thanks, guys.